we have Grace Hwang, who unfortunately was unable to make it in person, but she'll be giving a virtual presence from NSF. And then Megan is going to be giving a talk from NIH about funding opportunities. So are we able to stream Grace in? Here's Grace. Dr. Hwang, thank you for being here.
So I'm delighted to be here, and I'm sorry I'm attending virtually. It would be much nicer to be there with you all in person, and maybe hopefully next year I'll have a chance to do that. I am a program director at NSF. I am in the division of chemical, bioengineering, environmental, and transport systems, and I'm also a rotator from Johns Hopkins. I've been at the NSF for a little over a year and a half. And I'd like to start with the vision and the mission of the NSF. The vision of the NSF is to invest in basic research and in people through education to create scientific knowledge that can transform our future. NSF's joint focus on research and education was baked into our original vision. We were created by Congress in the 1950s to promote the progress of science and to advance the national health, prosperity, and welfare, and to secure the national defense and other purposes. And one of those purposes is well stated in our proposal and work policies and procedures guide, what we fondly refer to as the PAP-PG. Anyone who's written a proposal to the NSF is probably familiar with the PAP-PG. And if you were reading the PAP-PG and you saw what's listed here in the gray font, you might think that NSF does not support research with human subjects, which is actually not the case. There is only one directorate that does not support human research, and that is the Bio Directorate. The rest of the NSF directorates do support research with human subjects, but we do not support any clinical trials. As you can see here in the purple font, bioengineering and assistive information technology research to aid persons with disability also is eligible for support. So NSF by the numbers, very briefly, back in FY 2021, we were enacted with $8.5 billion, and 94% of that fund went right back out to research and related activities, which allowed us to review 43,000 proposals from 2,000 institutions, and we were awarded 12,000 of those proposals, supporting more than 307,000 people at the NSF. And the number has gone up. This is a super exciting time to be at the NSF. As you might know, we now have 8 directorates. The 8th directorate was formed about a month ago, and it's the Technology and Innovation Partnership Directorate. It's unique in that it works with all the other 7 directorates that serves basic science, and instead of being interested in basic science, the TIP directorate is about translation and youth-inspired research and to impact the community and the society in 2 to 3 years at scale and at pace. And I'm here today to tell you about a couple of transient funding opportunities that should be of relevance to you. In addition, I'll also talk about some of the more stable opportunities, which I'll refer to as core solicitations. So the first opportunity I'm going to tell you about was something that I actually was involved with back when the Convergence Accelerator program was in the Engineering Directorate. They have now moved to the TIP Directorate. And last June, we convened through the Convergence Accelerator program a series of workshops with over 300 virtual participants, 30% of whom identified as persons with disabilities, to learn from them what the community needed from us to improve their workforce inclusion and improve independence in healthcare and independent living. This was an event that brought partnerships or interest and attendance from NIH, NIDLR, and the VA, and we're pleased that last week NSF announced a new Track H, Enhancing Opportunities for Persons with Disabilities, through the Convergence Accelerator solicitation, and there's also a sister broad agency announcement which encourages companies to apply to this program. The Convergence Accelerator is a rather new program at the NSF. Its focus is on youth-inspired research and to deliver prototypes in 2 to 3 years. It's a cohort-based program, which means you have to be part of the first phase to be able to make it to the second phase. So if you're interested, letter of intent is due on May 31st, and the full proposal for the first phase is due on July 20th. First phase are smaller, $750K for 1 year, while the second phase are larger projects, upwards of $5 million for 24 months, and collaborations amongst teams are also encouraged. So this is a really big but transient investment. What I mean by that is that these accelerator topics change every year. We get ideas from the community, and the winning topics are posted as solicitations, but then they go away. So anyone who's interested, I would encourage that you sign up for the webinar. There will be one on May 4th and 5th, and you could sign up at the link on the slide. And if you can't, don't worry about writing things down, because I will make these slides available to Tay after my presentation. The second opportunity I want to tell you about is also a transient opportunity that was born out of the Emerging Frontiers in Research Innovation Program, which is a biennial competition that the NSF Engineering Directorate hosts. And we receive upwards of 300 ideas from the community, and only 2 topics historically make it. Topics historically are given $30 million for 2 cycles. We've currently just finished the first cycle, or rather, we're in the process of the first cycle, but the second cycle is about to begin. And the topic is brain-inspired dynamics for engineering energy-efficient circuits and artificial intelligence. Basically, the gist of this topic is there's so much new neuroscience insight that's being learned by the neuroscience communities throughout the globe. And yet, if you look at artificial intelligence, many of the deep learning models are based on the simplified 1950s point neuron model. And so much of this new knowledge isn't making its way into the hands of engineers. So our hope is that we can get neuroscientists and engineers working together to glean this new insight into engineered learning systems so that the engineered learning systems can become more brain-like. Be data efficient, energy efficient, learn flexibly, not suffer from catastrophic forgetting, etc. So if you can think about neuromodulation and cast it in the context of an engineered learning system, this could be a potentially relevant solicitation for you. And the nice thing about this solicitation, there's 2 phases. The first phase, well, actually there's 3 phases. The first phase is a letter of intent that's due on September 12th. Second phase is a 5-page preliminary proposal that's due on the 13th of October. And if you don't make it into past the prelim proposal, then the full proposal, you won't have to go through with the full proposal. And this actually, I think, helps everyone. And to ensure that if you're interested in applying, you want to make sure that your idea is in scope, you can always send me or ray@nsf.gov a 1-page white paper, and I'll go into examples of what white papers will look like in a few minutes. The one requirement of the BRAID topic is that theoretical neuroscience expertise is mandatory. And this just ensures that engineers and neuroscientists will actually work together. And the second thing that's a little odd about this is a minimum of 1 PI and 2 co-PIs are required. These programs run typically for $2 million up in 4 years. So that concludes the transient opportunities. Now I want to tell you about a landing page that my colleagues and I created at the NSF, time's flying, I would say in October of 2020 or so. And this landing page has all programs that support rehabilitation. And I think there's a nice overlap between rehabilitation and neuromodulation. So I'm going to just slide through a few of these programs, and keep in mind that most programs do not have due dates when they're a core program. And I'll try to make that distinction as I go through these slides. So in my program, the program that I manage, Disability and Rehabilitation Engineering, it's your proposal whenever you're ready. And we are interested in all kinds of technologies, new models, and new fundamental knowledge that could help with cognitive, sensory, physical, or other kinds of disabilities. DARE supports research directed to the characterization, restoration, and or substitution of human functional ability or cognition. The things that DARE really looks for is for the project ideas to be high risk and high reward. We're really looking for transformative outcomes. And we're also very interested in broadening participation. So we really encourage the inclusion of trainees with disabilities and the inclusion of persons with disabilities as part of the research team and our research design. As I mentioned earlier, We do not support clinical trials. However, it is possible to propose human subjects or animal studies with limited number of subjects. So you have to justify your sample size. And if you have specific questions, the best thing to do is to reach out to me with a one-pager. Similarly, the biomechanics and mechanobiology program, the engineering and biomedical systems program, and the mind, machine, and motor nexus programs may also be of interest to you. And the best people to reach out to there is Laura Cookshouse, Stephanie George, and Alex Vanessa. Now, moving further, I'm going to now talk about two cross-directorate programs. The first one is the Collaborative Research and Computational Neuroscience program. This program has been around for, I think, almost 20 years, and Ken Hwang is the cognizant PD. Typically, the solicitation is due in November of each year. And this program is actually set up with many different government agencies, including the NIH, the DOD, as well as partners in Germany, France, Israel, Japan, and Spain. The next program on this slide is the Integrative Strategies for Understanding Neural and Cognitive Systems program, or also known as NCS. This program actually requires two different fields come together to try to solve an otherwise intractable problem in the cognitive and neural systems domain. And there are four focus areas. One of them I think is really relevant to this group, and that is the neuroengineering and brain-inspired concepts and design focus area. This is where we welcome neuroprosthetics, neuromodulation systems, and the next due date is February 15th, 2023. And this FY23 cycle will be a Frontiers and a Foundations competition. So you can think of Foundations as $1 million up to 4 years. That's total dollars. You could think of Frontiers as 3 times that of the Foundation. And if you have an idea, you could email the NCS at nsf.gov to see if your idea is appropriate for the program. Now, last but not least, there is also ways, we also do support neuromodulation research through NSF's career mechanism. This is the most prestigious mechanism that we give to early career faculty. It's a foundation-wide program, and it provides stable support at a sufficient level and duration to allow awardees to develop their careers as outstanding researchers and educators. And there's a really strong integration with teaching and research in the career proposal. We do also encourage submissions from underrepresented communities and our non-R1 schools as well. The general guidance on the career is that they have to be at least 5 years in duration and a minimum of 500K for engineering proposals. There's no specified maximum, but I always encourage that you talk to your program director so you don't submit a proposal that's just way too large. The submission window is typically in July. And if this interests you, and if you're particularly interested in submitting a career proposal, with a biomedical engineering perspective, there is a workshop that NSF is offering called How to Write an NSF Career, Deconstructing the Word. That's going to be offered on the 25th and 6th of May. And the application due date is actually today. So if that's interesting to you, you want to try to capture this website on the right-hand side of the slide. And now there's another workshop that the Engineering Directorate offers. So the Engineering Directorate has many disciplines in it beyond just biomedical engineering. And that workshop, the registration is already closed, but there's a lot of really good resources that you could find there, and you could find at the second link on this slide. All right. So for my remaining time, I'll talk very briefly about the way proposals are graded at the NSF. Almost all solicitations and all proposals are graded through peer review under intellectual merit and broader impacts. There are some exceptions, for example, the EAGR, but I won't get into that today, and that is on an invitation basis only. And when you think about intellectual merit and broader impact, you can think of intellectual merit as encompassing the potential to advance knowledge, whereas broader impact is about the potential to benefit society and contribute to the achievement of specific desired societal outcomes. It doesn't hurt to ask your program director what specific questions reviewers will be asked to evaluate your proposal. I say this because, these are the generic 5 questions that are asked, that people are asked to review when they look at intellectual merit. But for the DARE program that I manage, you'll see that high risk, high payoff is in bold. Now, not every program cares about that, so there are other nuances, and it's great to just get the questions from your PD. And similarly, broader impact, I'm giving you some examples of what the DARE program really cares about, such as the inclusion of trainees with disabilities and participatory design. But there's actually no list, no prescribed list for broader impact, so it's good to get a flavor of what the program desires from your program director. And finally, this is a template of a one-page white paper. So instead of writing 15 pages, it helps us and it helps you to write us one page of your overview, your intellectual merit, and sometimes optionally your broader impact. That depends on the program director before you go out and write the whole 15-page proposal. And we don't have time to go through all of these requirements. So what I'll say is that I'll make these slides available and say that it's typically good to reach out to your program director 1 or 2 months before you actually plan to submit your proposal. And we at the NSF do our very best to get back to you with 75% of the proposals within 6 months of receiving that proposal. And some people are not sure when to go to the NSF or when to go to the NIH. So I put up this slide just to give you some high-level guidance. If your idea is more focused on engineering, high risk, high reward, proof of concept, you're probably will probably do better at the NSF, whereas we think of NIH as more of a place to go with proof of practice, even though NIH, of course, also funds basic science. So there's a healthy overlap so that good ideas aren't left behind. But anytime you don't know where your project where you should be applying to, it doesn't hurt to reach out to a program director. And sometimes I could even I'll even put people in touch with NIH program directors if I find that the proposal is just too far down the developmental path to be appropriate for DARE, for NSF in my program. Key take-home message is to understand the goals and requirements of the program, look at the program description, and read it thoroughly and carefully, and even look at some funded proposals for additional insight, and contact your program director. Get to know them, get to know their program, and even volunteer to serve as a reviewer, because that's a really good way to understand how a program works. Thank you so much for your time and attention. Are there any questions?
Thanks, Grace. This is Nick Langhall's Tay had to step away, but we probably have time for 1 or 2 quick questions from the audience, if anybody has any. If not, I guess I have one in general. When you mentioned that you will support, some limited human studies at NSF, what types of human studies might come into your programs?
We've looked at people are interested in prosthetics and soft robotics, gait analysis, wearable devices. So there's a whole variety of heterogeneous. I have a very heterogeneous portfolio.
Looking around, last chance, any additional questions for Grace? If not, let's go ahead and thank her again, and we'll move on to the next speaker. So next up is Dr. Megan Frankowski. She is a program officer at NINDS, the Institute of Neurological Disorders and Stroke, within my team. Her primary role is within the Brain Initiative at NIH, managing a portfolio of translational cooperative agreements and clinical trials in the areas of neuropsychiatric and movement disorders, among other things. And she'll be speaking about our various different NIH, NINDS, and other trans institute programs that we have ramping up across the agency.
All right. Thanks, Nick, for the introduction. My name is Megan Frankowski. I'm a program officer at our Translational Neural Devices program within the Division of Translational Research at NINDS, and I'm going to discuss some of the funding opportunities and Trans-NIH funding opportunities that we have available. So at the National Institutes of Neurological Disorders and Stroke, our mission is to seek fundamental knowledge about the brain and nervous system and then use that knowledge to reduce the burden of neurological disease. We support research on hundreds of neurological disorders, and you can follow the website listed below to see all of our different programs. I'm only going to focus on our translational space. In addition to basic research through R01 type grants that you're probably familiar with, we have many programs in the preclinical and translational space covering a broad range of topics such as biomarkers, small molecules, biologics, and devices. In addition, we have several clinical trial programs as well as robust small business program that supports research from the proof of concept stage through clinical trials. NINDS is also actively involved in the Trans-NIH programs, including the BRAIN Initiative, HEAL Initiative, and the SPARK program. So in this talk, I'll be focusing primarily on the translational space, which I said. Here is shown an overview of the various funding opportunities that support technological development, from concept generation and device optimization through early stage clinical trials. Today I'll be focusing on programs we offer in bioengineering, a few from the BRAIN Initiative and our Translational Neural Devices program, as well as the recently created Blueprint MedTech program. The NIH bioengineering program's goal is to encourage basic, applied, and translational bioengineering research that could make significant contribution to improving human health. Currently, we only have one opportunity available, and that's through the R21 Exploratory Bioengineering Research Grant. These grants support high-risk, high-reward research in order to establish feasibility of technology within a multidisciplinary approach and to generate preliminary data that will be necessary for future research. So in this grant, preliminary data is not required. The next set of programs I'm going to discuss are available through the BRAIN Initiative, which includes participation from 10 of the 26 NIH institutes and aims to develop and apply new tools for understanding how neural circuits underlie complex behaviors in health and disease. The BRAIN Initiative provides a wide range of funding opportunities from neural recording and stimulation to dissemination and neuroethics. You can see more of the opportunities with the braininitiative.nih.gov link below. Funding for the BRAIN Initiative has been steadily increasing since its inception. The initiative recently received a $100 million increase for fiscal year 21. So with the addition of funds from the 21st Century Cures Act, funding for fiscal year 23 is looking very good. Through the BRAIN Initiative, we aim to support technology and development for invasive device recording and stimulation in the CNS through a pipeline of funding opportunities. In addition to the funding opportunities I'm going to present shortly, there are many other opportunities, such as those listed here, depending on the stage of technology development. I'm not going to go through each and every one of these, but you can find more information at the address below, and I'll share my slides with Tay when I'm done. So my primary role as a program officer in the devices program is to manage a portfolio of BRAIN Initiative cooperative agreements to support development and recording of stimulation technologies to diagnose and treat CNS disorders. Projects that incorporate these cooperative agreements are a little bit different from standard grants. They involve participation of NIH program staff in negotiating the final project plan, negotiating milestones before the award, and yearly monitoring of research progress. For the BRAIN Initiative, we currently have two opportunities for projects focusing on these stimulating and recording devices. The first is our UG3-UH3 award. This is a phased award. In the first phase, investigators can complete engineering work. They can perform verification, validation, small, large animal testing as needed to achieve FDA and IRB approval. And after this stage, they're expected to move to the UH3 phase, which is a first-in-human or small early feasibility trial to collect safety and efficacy data. We also have the straight-to-UH3 option, which supports that same small clinical trial. These opportunities were recently reissued, and there were some changes that were made, which include that all of these applications need to be of significant risk, which requires an IDE submission to the FDA, and that prior to moving on to the UH3 for the UG3-UH3 or prior to issuance of notice of award for the straight-to-UH3, applicants need to have their IDE and IRB approval in hand. The BRAIN Initiative also supports dissemination of technologies. We currently have a funding opportunity through the U24 grant for technology integration and dissemination, as well as administrative supplements for currently funded projects to help with dissemination to activities. Finally, there was a recent notice of special interest from the BRAIN Initiative for small business applicants to help bring technologies to the marketplace. While not limited to BRAIN opportunities, applicants to our program can choose to work with industry partners from our public-private partnership program, which aims to facilitate collaboration between investigators, manufacturers of devices. Through this partnership, device manufacturers provide technical support and/or devices. We currently have 8 industry partners participating in the program, including Boston Scientific, Medtronic, Cortec, and Surtec. If an investigator doesn't choose to participate in the program, applications should include a letter of support from the manufacturer. The NIH and the BRAIN Initiative are committed to building a strong community of researchers who embody diverse perspectives. To help facilitate this, we hold a BRAIN meeting every year to allow researchers an opportunity to present their findings and to provide a great place for trainees to network. This year's meeting is going to be hybrid. It is scheduled for June 21st and 22nd. The in-person sessions will be held at the Natcher building on NIH's main campus. Registration's free. However, if you plan on attending in person, I would recommend registering sooner rather than later, since there's probably going to be capacity limits based on the size of the event space. So in addition to those BRAIN-funded opportunities that I described, we also have 2 opportunities within our Translational Neural Devices program. Both these UG3, UH3, and the U44 for small businesses are phased awards that involve cooperative agreements similar to those BRAIN opportunities I just discussed. These projects support development, optimization, and translational activities of therapeutic diagnostic devices, in addition to a small clinical trial. There are some key differences between this program and the BRAIN program. Specifically, in this TND program, here applications can include invasive or non-invasive devices. They can be significant risk or non-significant risk, and they can cover both the peripheral and central nervous system. The final opportunity that I'd like to highlight is our newly implemented Blueprint MedTech program. This program was developed to help support developers of novel technologies who face many challenges along the path from bench to bedside. The goal of the program is to provide support needed to sufficiently de-risk technologies to the point where industry partners, government, investors are enticed to bring and invest these new diagnostic and therapeutic products to market. The goal of this program is to provide funds for supporting the medical device development activities led by investigators, and then complemented by additional preclinical, clinical, regulatory, and business development resources and expertise, which will be provided by the MedTech Incubator. Some of the services that are included in the incubator include planning resources to support concept development, access to translational services such as prototyping, bench testing, large animal testing, and biocompatibility, assistance from consultants for issues involving regulatory, reimbursement, intellectual property, and advice from industry experts. All of these resource packages can be tailored based on your project's needs. In collaboration with Blueprint MedTech, the BRAIN Initiative recently issued a notice of special interest. Through this notice, the BRAIN Initiative will provide support for applicants to the Blueprint MedTech program that focus on novel invasive neurostimulation and recording devices, specifically for the CNS. And they will also fund non-invasive devices with the caveat that these devices should achieve sub-millimeter resolution at the cortical surface in depth. And almost finally, outside of the NINDS, there are other ICs that support device development, such as NIBIB. There's currently this Debut Challenge, which is an undergraduate team challenge focused on addressing unmet clinical needs in device development. There will be general awards co-funded by NIBIB and a public-private partnership with VentureWell, along with topic-specific awards by various ICs, such as NCI. For more information, you can look at the link below or just by Googling NIBIB Debut. If you have any questions about the programs that I discussed today, please feel free to reach out at us at the email address below. If you're interested in new opportunities on the translational side at NINDS, please subscribe to our listserv via this QR code. And I don't know if I mentioned earlier, but we have flyers at the front of the room with more detailed information about all of the programs, including those that I didn't go in depth on. So feel free to grab one. And then finally, we have several job openings for program directors, review officers, project managers, and program specialists within NINDS. So if you or someone you know is looking to make a move, NINDS provides a great place to work while staying involved in the science. And that's it.
Thanks, Megan. So I guess similarly, we have time for one or two quick questions, if there's any from the audience.
Maybe I can just talk my June voice here or not.
Sorry, good.
I will use the mic. I have a question about the NIH blueprint versus some of the other programs when it comes about technology translation. So when should one think about blueprint versus the others? The specificity, that's my question.
That's a great question for Nick.
Sure, I'll go ahead and handle that one. As you noticed kind of in the descriptions, right now there is definitely some overlap across the various opportunities. So NINDS has been operating our programs for many years in this space. A lot of what you're noticing is us working with now other partner institutes, both within the BRAIN Initiative as well as the Blueprint groups, in order to be able to kind of branch out these activities and increase the broader participation across NIH. In terms of which program you're applying to in the specifics, our general advice is reach out to us with an AIMS page, and we can help point you in one of the directions. Specifically with the Blueprint MedTech, as Megan noted, a lot of what we're also standing up is the consultant and contract and incubator hub resources. And so if you're interested in being able to take advantage of those resources, that's definitely a good reason to steer towards the Blueprint MedTech programs.
Thank you.
Okay. I guess seeing no other questions, we'll go ahead and move on to the next section.